coming. To stream. I'm coming. Hello? Hello, can you hear me?
Yeah, yeah, can you hear me?
Yeah, yeah. So this is Diogo, the moderation on the as a moderator today, and this is Adefemi, who is our speaker.
Good evening,
Uh,
Adefemi.
Yeah, Diogo. Yeah, good evening.
uh,
Yeah,
so
good evening.
but I tested it to check whether people can hear us. We are live.
Oh, okay.
Okay. So let me just move to the countdown stage. Okay. So
Good
this we are
evening.
starting now.
Good evening, everyone. Can you hear me? Um,
I can hear you. I can hear you. Yeah, I can hear you.
okay. All right. Thank you so much. So, welcome everyone joining us from every part of the world where you're joining us from today. My name is Diogo Anekwe, and I'm going to be the moderator for today's study series. This is study series week 2, and week 1 was super pumped. And today we are talking about security and zero trust in AWS. So, if we have cloud security people in the building, can they make some noise on the chat so we can start?
Can you hear me, Adifemi?
Yeah, I can hear you 100%.
Yeah, I think we lost Diego, so we'll just wait for. This is 6:05, and we'll just give like another 2 more minutes. You can start your present. We'll read your bio for people to understand, know you, and before you begin your presentation. And so we just wait for another 1 more minute and we start. Thank you for the time.
Oh, okay, that's fine. Trying to share my screen.
Okay. So, welcome everyone to the study series 2. Last week we had Dr. Anil from AWS who took us on Amazon Bedrock on AWS, and he spoke about some.
Can
I said last week,
upload the
yes.
do you guys
So
have the
I would,
slide here?
yes, we do have the slide, and I will share it. I will share my screen.
Yeah, please. Yeah, please.
Okay,
Oh,
so
thank you.
I will. So Oluwayomi Adefemi is a DevOps and a cloud engineer specializing in building scalable, secure, and high performance infrastructure across AWS, Kubernetes, Linux, and Windows environment. With deep expertise in platform engineering, reliability, and cloud architecture, it designs resilient systems that enable organizations to operate efficiently at scale. He currently contributes to enterprise transformation at GloPro Procurement System, where he supports the delivery of e-procurement and procurement as a service solution for multinational corporation and large enterprise across Africa. His work helps drive cost efficiency, visibility, and operational excellence in direct and indirect spend procurement. Beyond engineering, Oluwayomi is deeply committed to talent development and ecosystem growth. He serves as a DevOps faculty at Learn Academy, where he trains and mentors aspiring engineers using real world industry relevant tools and practices. He's also actively involved in Tech Bridge Africa Street to Silicon initiative, helping unlocking opportunities for undeserved talent by equipping them with an in-demand tech and AI skill. Known for complex concept and guiding professional into successful DevOps career, he combines strong technical depth with a passion for mentorship and community impact. His approach is grounded in continuous improvement, reliable engineering, believe that technology should not only scale system but also people. So welcome Oluwa Adefemi Oluwayomi to our presentation today, and he'll be speaking on security and zero trust on AWS.
Oh, thank you very
Uh,
much.
So,
Thank you very much.
uh,
Um, so my name is Oluwayomi, and thank you for having me. So I I trust we are going to have a great time together this evening. So let's go straight into business. So organization who has made security top priority um, over the years, excuse me, has been able to gain customer trust, and also they've been also be able to unlock and get new digital business opportunities, right? And also individuals who have made security their top priority over the years have become so valuable to their organization and also to their community. But it has been observed, as we have discovered, that the perimeter security model, which defines security perimeter um, as the separation from non-trusted entity to trusted entity in network zones, is highly insufficient. Um, Reason why organizations and individuals have embraced zero trust model, right? Not saying We're not saying the traditional security perimeter is dead. No, we're just saying is insufficient because it was unable to handle the issues of identities, right? Once the attacker gets into our system, uh, what do they do? They have access to the system, right? So it makes that perimeter, that network, traditional security model insufficient, right? So I don't know if my screen is being shared.
yes, you have everything is shared now.
Oh, okay. Thank you. Thank you. So, and this will lead me to the second slide that talks about security models, right? Um, okay,
Hello,
security models have
can you hear
evolved
me?
model, and you can see that early enterprise, they built security around clear boundaries. Organization ran applications in single data centers. Users worked from controlled environments. This security architecture resembled a fortress, right? And strong defenses existed at the edge, right? But this model worked basically because infrastructure was centralized, users were predictable, and network boundaries were very stable, right? So, but this perimeter model was broken by three structural changes. And structural changes are cloud computing removed physical boundaries. And if you look at the growth of and the trajectory of cloud computing, every year, if we are not 10xing from our previous year, there's always a quantum leap from our previous year, right? So cloud computing removed the physical boundaries. Remote work eliminated location-based trust, right? APIs and microservices exposed our internal systems externally. So at the same time, attackers adapted attacking infrastructure, which is expensive. They began targeting identities, right? So they began targeting identities, which is very important because targeting infrastructure, right? It's no more visible for them, and it's easier for them to target identity to steal credentials and to be able to gain access. So this really broke the perimeter security model that you know gave an assumptions that okay, once it's internal, it means trusted. Well, that assumption became a liability, and this leads us to the point that say traditional security model is not more sufficient anymore because it's assumption. The assumption that internal, right, equals trusted no longer holds, right? So it no longer holds. This leads us um, which showed us that officially from about 2020, security models has formally shifted towards zero trust. And I had to put some of these quotes here to just indicate what the authorities are saying about zero trust, right? So, for example, Gartner predicted in 2020, I think 2021, that by 2025, 60% of organizations will embrace zero trust, you know, starting for zero trust as a starting place for security, basically. But if you look at it, if not surpassed, if this prediction has not been surpassed, we have closely gotten to this point because, for example, AWS has gotten better and better and better year on year, right? As regards zero trust. So, and also the National Institute of Standard and Technology defined zero trust architecture in this article in year 2020. So, and if you look at it, basically, you will see that subsequent Gartner reports, for example, in 2022 to 2023, they also reinforced that zero trust is a strategic security model, particularly because it has reduced majorly lateral movement and identity-based risk. So lateral movement simply means like an attacker gets access into your system. So instead of stopping at one compromised machine or account, the attacker begins to move sideways across the environment. For example, you can move from staging to your prod environment, into your dev environment, just jumping from one system, one container, one service to another, right? And just to find more valuable targets, right? And this is just to show us that organizations who have not embraced zero trust, or even individuals who are not looking towards zero trust, right, will be at a risk. Even if you look at it, even from the beginning of the year, you will observe from the beginning of the year that even attacks that have happened on organizations, right, most of them, although we are waiting for the report, right, most of them, right, is as a result of stolen credentials, MFA fatigue, right? So this reinforces what we are talking about, that authorities started definition of zero trust in 2020, prediction was made in 2021. Now we're in 2026. You will see that a lot of organization has embraced zero trust, right? And them embracing zero trust, it takes us to the next slide, which says attackers no longer lead to breaking. They don't need to break in. Now they gain access. Like modern attacks target identity, not infrastructure. Like I said earlier on, they will rather steal credentials, right? Hijack sessions, exploit access misconfiguration, right? And if you look at the next slide, this gave real world examples, right? The attack, the attacker in Uber 22, he gained access. Although Uber published this in their security blog, right? He gained access by attacking by using a stolen credential with MFA fatigue, which is also known as push bombing, right? Okta in 2022, support account was compromised. It led to customer exposure. Also, Microsoft in 2023, if you guys could recall, an MGM result. This was widely reported in Reuters, right? Social engineering led to identity takeover, system disruption. So, supporting this is just to support the point of the statement I made that attackers have adapted, right? Instead of attacking infrastructure, now they are now attacking. They are attacking, gaining asset and breaking in, hijacking sessions, reward examples. And if you look towards the end of last year and even up till early this month, you will see that attackers find it more easier and more effective to steal credentials, right? So, and if you look at the Verizon data breach investigation and their reports, it consistently states that credential abuse is one of the top initial access vectors. If it's not number one, it's one, right? The majority of breaches involved stolen or abused credentials. Majority of breaches involve stolen or abused credential. If it's not stolen by an attacker, it's abused by by a user or by a service, right? Basically. So which leads us to the next slide. Okay. Leads us that you see that means perimeter security is no, you have to go back. Sorry. Yeah, it's no longer sufficient. So from what I've been saying, you see, it's no longer sufficient, not because you know it's no longer sufficient anymore. And why? If the attacker can log in using valid credentials, will the firewall stop them? That's the question I want to ask. Will the firewall stop them? Will the network location matter at that point? Right? Internal systems are already exposed. So the real question that we need to answer is what happens when the attacker or an attacker is already inside, right? What happens? Traditional perimeter models are inadequate for modern system, right? And that is why we're embracing, or organizations have embraced and improving on zero trust, right? So it leads us to the next point that says access decision must be dynamic and context aware, right? It must be dynamic, right? Instead of granting access once, zero trust evaluates by asking questions like who is making this request? What are they accessing? Right? Where are they coming from? And is their behavior normal? And this term is known as continuous authorization. You're not just granting access once, right? So access decisions is now dynamic and context aware. And questions is being asked. Who is making this request? What are they accessing, right? Why, where are they coming from? Excuse me, whether their behavior is normal, and he answers the question of continuous authorization. And he also explains that zero trust is enforced also through concrete and testable principles. For example, um, verify explicitly, It means every request must prove who is making it. And that solves the issue of identity. Who is making this request? And under what condition are they making the request? The condition means the device, the location, the time, the behavior. So no request is trusted just because they are inside the network, right? That's what verify explicitly means. It means who is making this request? Under what condition are they making example? And this, for example, an example is a user via, please, you have to go back to the previous slide. A user logs in via AWS console management, right? With MFA. API calls are signed using AWS signature for, IAM policies using conditions like IP address restriction, MFA, you know, whether it's true or false. Also, we have the least privilege. It means giving identities only the permissions they absolutely need, nothing more. This reduces when an attacker already have credentials, what they can do. You know, an example of that is, I am policies already allows you to read an S3 bucket, but you cannot delete it. A Lambda function can help you write logs, but you cannot access the database, right? Because you don't have the permission, you don't have the right to do that. So you don't have the privilege. That's a better word. You cannot access the database. EKS pods is tightly scoped using IAM roles, IRSA, right? So that explains the point of the least privilege. And also the next point, which is assumed bridge, right? It means if credentials, if they are eventually stolen or the system is compromised, what do we do? This focus on containment, not just prevention. For example, an EC2 instance that has been compromised, right? If an EC2 instance has been compromised, can the resources be only the allowed resources? The role that's what it can do. A compromised EC2 instance can only access resources allowed by its IAM role, right? Stolen API keys too, you know, still restricted by policy scope and short-lived credentials. This is just talking about the assumed breach, right? And these are testable principles for zero trust. Also, we have micro-segmentation, which isolates workloads and limits communication paths. It means you break your environment into small and controlled zones. An example of this in AWS is VPC design, right? We have the public subnet, we have the private subnet, we have the database. Also, another one is security group, right? That only allows specific ports between services, right? They allow specific ports between services. And also, when you talk about Kubernetes, EKS, right, in AWS, network policies restrict port-to-port communication. It separates IAM roles per service. So this segmentation isolates workload, it limits communication paths, right? And also the last point, which is continuous monitoring, continuous monitoring where you observe and analyze all activities. You don't just secure, you continuously watch and verify behavior. um, AWS CloudTrail will log every API calls. CloudWatch monitors metrics and anomaly. Guard Duty detects suspicious activities, right? Suspicious activities, maybe an unusual API usage. You set alerts for unusual login location, privilege exploitation attempts, that. And there's security. This leads us to the image, right? That's slide 8. I don't know if we're on the same slide. So this image is just showing us, I think you need to go back 2 slides back. This is how, right, this image, it shows us how AWS demonstrates zero trust at scale. Everything, every request is verified. That's a better word. Every request is verified. And how are they verified? Whether you are coming via the AWS Management Console, which is a web-based, or the AWS CLI, or maybe an application calling APIs, right? Security does not rely on network trust. Instead, each request is cryptographically verified using TLS encryption, right? TLS, transport layer security, and it encrypts data in transit. And also AWS signature version 4, which you can also see, it signs and validates requests and is authenticated verifies identity, authorize checking permission every single time, right? It checks permission every single time. And this image just shows us the prominent example of zero trust in AWS. How millions of customers interact with AWS every day using the AWS management console, right? And or the securely or the API's core, right, that is secured, right? This is just showing us whether from the browser, whether CLI or applications, right? Ultimately, all this method of interaction reach a set of web service endpoints, right? And before it gets to the application, whether the S3 bucket, the Lambda functions, the EC2 instance, it needs to go through this layer of security where every request will be verified. Do you understand? Every request. So there's absolutely nothing about the security of AWS API infrastructure that depends on network reachability. Each of these signed API requests is authenticated and authorized every time, right? Rate of millions upon millions per request, right? It's authorized. So, and this, like I said, my opening statement, that organizations that have made security their priority, right? They've gained customer trust. They've made the customer more confident in using, their services, right? So this takes us next, which talks about AWS enforcing security through controlled interactions, right? And identity may request, you know, how an identity initiates an action, whether the identity can either be a user in the AWS management console, a script using AWS CLI, an application using IAM role in EKS, right? So in AWS, everything starts with an identity. Everything starts with an identity, either an IAM user, IAM role, or a federated identity, right? Which is also known as SSO. So the second one is authentication verifies identity. AWS verifies that the request is genuinely from the claimed identity. You know, is this the person? It's you have to AWS has to verify it, and that is why you see that AWS has embraced zero trust is not today, right? So, and this is done using the transport layer. If you recall the image I displayed in the last slide, transport layer security, it secures communication, and the AWS signature version 4, it cryptographically signs the request. So, authentication verifies the identity. Authorization evaluates permission. Are you allowed to do this? And this uses IAM policies, right? It deny rules, resource policies, that means S3 bucket policies, conditions like IP address, time, device, location. This privilege is also enforced here. So the fourth controlled interaction, right, is action is executed. And if both authentication and authorization pass, the request action is performed, right? So whether it's to read from S3, is to deploy EKS, is to query a DynamoDB, right? If both the first layer, the second layer, and the third layer pass, action is executed. And if anything fails, no action happens. So that's what action is executed basically means here. And activities, they are logged. Activity is logged. Every action is recorded using, like I said initially, CloudTrail, who is making this request, what action was taken, where and from where, and this enables auditing, threat detection, and forensics. So this leads us to the next slide that talks about identity as the security boundary, right? Like I said initially, in AWS, every action starts with an identity. Identity could be a human identity, I am user, whether a federated user, an application, I am role attached to it, right? I am role attached to it. I am role attached to rather Lambda or EKS. A service could be AWS service assuming roles to act on your behalf. So, and no identity, no access. No identity, no access. And I think it talks about the authentication. Who are you? I think we've talked about is the process of verifying the identity of making requests. We talked about that already. Um, let's go to the next slide. So, yeah, it talks about the what, who can do what on resources, whether it's the I am use, the I am rule, the I am. So, and basically we have types of policies. We have the identity based policy. The policies are attached to users, roles, and groups. For example, of an example of an identity based policies, right? Under policies, I am policies, you know, the effect can be allowed, the action can be maybe get bucket, and the resources, right? You can attach these policies to users, you can attach it to roles. Resource-based policies, you can enable cross-account access, right? You can attach directly to resources like S3, SQS. We also have permission boundaries, we control policy, SCPS, right? Permission boundaries. And for the I am policies also, that's the rule of the game. Policies, they are the actual enforcement mechanism, right? Behind authorization. The who can do what on which resources and under what condition, right? And also, I think I want to talk about the I am rule. Okay, but let's move on. Okay, yeah, I want to talk about the I am. Please go back to the next slide. Okay, thank you. Not this. So, the I am user, the human identity, what it is, and I it basically represent a specific person or a workload, right? Which uses long time credentials inside an Amazon Web Services, right? It can be a username and password that use console access. It can be access keys. Maybe they are making API calls or CLI access, right? So, but for AWS, the best practice, right, is avoid using I am users for day-to-day operation. So it's preferred to use like Federation instead, SSO instead, right? So, and we also have I am roles, right? So is a temporary identity that is assumed when needed. It's not permanently assigned, right? It's assumed when needed, application, an EC2 instance, attach I am role to, read EC2 to read S3 buckets, right? So that's cross the last one, I am policy. I think I spoke about that. So I think we can now go to the next slide. Thank you. So protection and visibility, it completes the security model, and you can see you have to data and observability. Data protection, it completes you protect data everywhere. That's and how do you do that? Encryption, right? Encryptions ensure that even if access is gained, data remains unreachable, right? And AWS, when data is at rest, is encrypted using AWS key management services, and you can integrate it with services like Amazon S3, Amazon EBS, or Amazon RDS, right? So logging, that talks about zero trust cannot function without visibility. You have to log every action. Recording every action, it provides verifiable record of all activities in your environment, right? And you can use core AWS logging services like CloudTrail, CloudWatch, AWS. For example, a developer can delete an S3 bucket, right? CloudTrail will log it, identity use, the time of action, the API call when the bucket was deleted, and the source IP. So, please can we go to the next slide? Zero is not. So now this brings us to the definition of zero trust. Yeah, I've been talking about zero trust.
Hello, Adefemi, can you hear us? Hello, Adefemi. I think we lost him. Just give us time so that he can join. I think we lost him. Yeah, maybe due to network.
So it's not just Zero Trust is not just a product, right? Like I've
Hey,
so everything
Adefemi,
I've
we
been
lost
explaining, it's
you a little bit.
just to bring us to this point that Zero Trust is a security model, right? And okay, I think I'm live. So it's a model, right? That entity, component, or services or user is trusted by default. And all what I've been saying is just to explain this definition, right? And no assumptions. No assumptions are made about their integrity. So zero trust on AWS is a security model centered on the idea that access to data should not be determined solely by network. And that's what you see that I've been explaining for the past 20 something minutes, just trying to push home this definition. So next slide, please. So zero trust is implemented through coordinated AWS control. Yeah, I talked about the user identity verification, context evaluation, the access. I talked about that previously, and also continuous monitoring. Very important. Continuous monitoring. Never trust. Never trust. Always verify. Every action is logged. Every action is logged. So that is very key and important. So I think the next slide. So this is the first use case. There are several use cases, right? But we're just going to work with these two. Human to application, use case, right? Where an identity, an AWS user authenticates via SSO, and we had to I had to simulate this situation, right? These credentials are bound to a session that enforces MFA, and it expires after 15 minutes. So in this scenario, right, the major focus is on identity protection against credential leakage, demonstrating how short-lived context-aware, you know, prevent attackers from reusing stolen credentials. So basically, if you look at these projects, it's just demonstrates how zero trust network access operates, right? So in the traditional security model, right, if an attacker steals your username and password, they can walk straight into your system. But zero trust network access changes that by saying if you have access to these credentials, that's not enough. Access is temporary, right? The system is context aware, and access can expire. So please, can you go to the next image? So if you're seeing the next image is loading here. Yeah. So this is the role. The role has been created. Um, you can see if read only role has been created. Um, under I am under roles. So it has been created. You can see it. It was created using was simulating a real AWS account. So please go to the next slide. The role has been created.
Hello, Adefemi. We just lost him again. Just give us some few minutes. I guess he will join again. We are waiting for him. The network has not been favorable, but I guess in less than 30 seconds he will join us back again.
Thank you.
Okay, we have him back again. We have him back again.
Yeah, I'm back. This is the policy.
Okay.
Yeah, thank you very much. Yeah, thank you. So you can see allowed to list the bucket is allowed to get buckets, right? So please can you go to the next slide? So this is the I am policy. I'm showing you that this was created. That's why I'm showing you this image. And okay, before you go to the next slide, you know, it explains there the, the conditions, right? The conditions, yes, explains the conditions in I am. You can see we have effect, we have allow, we have the action, we have the resources, we have the statement. Oh, okay, thank you. Now you can see um, he asked for my MFA token. By the way, MFA was enabled, right, for the demo user. This was a live token from my authenticator app. I imputed it. I assumed the role. Temporary credentials were issued and it was expired, right? It expired at a certain time, like after 15 minutes, right? After imputing my token code from my app, you can see from the screenshot, I was able to list the bucket. I was able to get details from the bucket, right? Now, if you look at the step 3, attackers will use the credentials after expiry. After it has expired, you can see that the attacker tries to use the credentials, um, the invalid token. The provided token is malformed, otherwise invalid, right? So he was unable to list the bucket. And these are the logs of everything that happened. It was successful when he assumed role, right, using the token. It was successful when he was about listing, when he listed the bucket, right? When he got listed the object in the bucket, right? Whether it's the data.json or the report. But when the attacker assumed and got the token, right, to reuse, it has expired, right? And the attacker was enabled to do other things in the system. So this is just like a use case trying to just drive home the point of zero trust on AWS, right? Please, I don't know if you can move to the next use case or the next. So this image just shows the final simulation output. So the next use case, right? It was also a user, but basically the user is allowed to read. I don't know if you guys can still hear me.
We can hear you, sir.
Oh, thank you very much. So the next, I don't know if you can move my slide to the next. The next use case, right? You know, is a data protection, human to data control, right? The access to storage does not equal access to data, right? And the user can access the storage, but the users cannot decrypt. The user cannot decrypt. And what's how I provisioned this? I used Terraform to, create these resources. Terraform created the resources, basically. Okay. Terraform created these resources. It created the key, the KMS key, created the KMS alias, it created the S3 buckets, SSE configuration, public access blocked, right? I am policy, right? So if you look at it very well, if you look at the JSON file, that's the policy, the JSON file, you see the seed root full control, right? It gives the account root full controls, which requires safety net, right? Without it, if you lose all admin access, the key becomes permanently orphaned, right? But if you look at the second statement, right, it allows S3 to, it doesn't allow S3 bucket to generate key, you know. S3 bucket can encrypt objects, but without S3 bucket cannot generate the key, they cannot decrypt the key rather. The demo user rather I said the demo user cannot decrypt the key. The demo user can also not generate the key. But the demo user can upload. So the demo user, so this is just an ad enforcement, right? I explained that an explicit deny in AWS is absolute and it overrides every allow from other policies. Even if someone later accidentally grants this user KMS access, right, via another policy, this deny that you're saying will win, all right? It will win. Um, So if you notice, there's no KMS action anywhere. So the user can reach the bucket, it can list all the content, it can request objects, but the moment S3 tries to decrypt, right, the object using KMS, the key policy denies and fires the whole operation, denies, and the whole operation fails. So this is just to simulate a real scenario, right? That a user or attacker who has valid storage credentials, can hit an encryption wall if he tries to do or go outside the policy, right? So if he tries to go outside the policy, um, my slides are not changing, but I think I've spoken to the second use case, right? So the takeaway is identity is alone is not enough, right? For this use case, you need a valid IAM credentials with S3 access, right? Without the key, it means nothing. Encryption is the enforcement layer, is not just a compliance checkbox, right? Explicit deny is absolute. No other policy can override it, and that's the strongest control in AWS IAM. So I will end by saying security is no longer about keeping attackers out. So it's also about ensuring that even with valid access, right, they cannot escalate, they cannot move and extract value. So thank you very much. I don't know. Yeah, thank you very much. Thank you. Yeah, I can hear you
Y-
100%.
Yeah, I'm back. Sorry, apologies. Can you hear me?
Yeah, I can hear you.
Yeah, apologies. The internet network actually does went and came back. Apologies, and I was for everyone who was on the call for what happened. We truly apologize for what has happened. Thank you.
I think we've lost him. Hello, can you hear me? So, okay. Starting from, the biggest mistake is organization wants to start from the network segmentation instead of identity, right? And without strong identity controls, segmentation becomes complex and ineffective. So attackers can still move using valid credentials segmentation. Yeah, I think we should have, yeah. Do you have the quiz? Yeah, I think you can go to the next step if yeah.